Okay, so am I audible? Just type yes in the chat box if I am audible. Type yes in the chat box if you're able to hear me. Okay, and are the slides clear? Just type yes if the slides are clear. Okay, all right, good. So let's get started without wasting any time. So this is a new kind of webinar. This is something, the tool was already there. Align is an open source tool for analog circuit layout synthesis. And there will be completely hands-on the webinar that you are going to observe right now. It will be completely hands-on, which means that you're going to see labs, real life labs in the webinar itself. So, and of course, there will be some content which we'll be sharing after the webinar also for all of you to practice. And then there is another program that we are going to launch on top of the Align tool, which Syed, the speaker, is going to mentor all of you. Those are going to come, but why this webinar is important is because just to show you, the scale at which the open source framework is increasing, and there is a reason for that. VSD has been involved in a lot of analog design in the past, and because of that, we realized that there is a problem that the analog part is something which we had to do. Which we had to do manually, and there are close to hundreds of circuits which we did manually, and that was kind of tiresome work for VSD and its intern. So we basically explored one of the tools, Align. It was all the details will be shared with you in some time from now. But we kind of launched this as an internship program. We basically explored the tool Align, and one of the participants of the VSD internship program, Syed, and there are many more. Syed is one of them. We basically try to explore the tool and try to take a sample circuit and see how it works. So fundamentally, if anybody is a very basic student over here, for them, just to give you a little bit of background. So whichever chip you see in the market, whichever it could be any kind of chip, any kind of microchip which you see in the market. It is generally not only digital. It's a mix of digital and analog. Generally students who are doing physical design courses from any of the institutes or any of the colleges, just remember one thing, that physical design is never digital only. It's a combination of analog and digital, and analog being the major part of it, because your whole world is analog. If you look into this, your 230 volts socket points, those gives you AC signal. And there should be a mechanism to convert the AC to DC, and that's why any chip which you see, it's always a mixed signal chip. And the work that you all are doing, or the work which the freshers over here are aspiring to do, it's mostly a mixed signal physical design, not only digital physical design. Okay, so this particular webinar focuses only on how do you generate the analog blocks for it to be used in a bigger mixed signal physical design flow. The mixed signal physical design flow will be a part of a separate webinar, which will be a follow-up webinar of what you're going to learn over here. But this one will be focused only on how do you basically generate the analog blocks, or how do you automate as far as possible the analog portion of it. You build circuits and you start doing custom layout, which is again a very preferred way in the industry. And the reason is you can control a lot of parameters in the while doing custom layout. But this is a kind of exploration towards a different direction, where we are trying to build or trying to build the layouts automatically using the Align software. And it is not straightforward because I remember all the interns working day and night to explore the tool. They actually literally opened up the entire tool and modified a lot of things within the source code itself to make sure most of the things is automated. So it's not straightforward, but the good part is in this particular webinar, we have documented all the changes that you would need to make this particular tool work, and you can now extensively use this tool and experiment with this particular tool left and right. You can explore, and you can also contribute to the Align software. Okay, so without wasting any time, let me introduce you to the speaker. So the speaker is a student. If you look into person, Sayyid Imaduddin, he's not an expert industry person. He was just a student. But the moment you watch his webinar, my whole team actually reviewed his whole webinar last night, and the way he put out the whole webinar and the way he has put his thoughts in this particular webinar, you might see as an expert who is speaking in this particular webinar. In fact, I was very amazed by the way he spoke the entire webinar about, and he's going to talk about it in a couple of minutes from now. So he's an undergrad student, just like most of you. He's also an undergrad student, so very passionate about sorry, I think I got disconnected. So Syed is an undergrad student. He's right now doing his electronics engineering at Aligarh Muslim University, and he's very passionate about analog and mixed-signal physical design. He was also a winner of one of the hackathons which we conducted a few months back, and I would like to begin by unmuting Syed, and he will quickly introduce himself to you, and then we'll start the webinar. So, Syed, can you just quickly introduce yourself to all the participants, and then we'll start the webinar?
Yes, sir. Am I audible?
Yes, you're audible.
Oh, hello everyone. My name is Sayyid Imaduddin, and I'm an undergraduate student pursuing a degree in electronics engineering at Aligarh Muslim University. I am currently interning at VSD, where I have been fortunate enough to gain practical experience and learn about the VLSI industry by working with open source EDA tools like xschem, Magic, Ngspice, Align, OpenRoad, and OpenFSOC. So during my internship, I have had the privilege of working alongside some amazing fellow interns who have been incredibly helpful in completing my weekly tasks. And collaborating with them has been beneficial for brainstorming solutions and sharing ideas. And we have supported each other throughout the internship. And I'm
Yes.
also grateful for the opportunity to work with highly skilled professionals at VSD who provided invaluable mentorship and guidance. And their insights into the industry and the task at hand have helped me grow as professional. And I'm truly grateful to VSD for providing such an industry-oriented internship, which has given me a great learning opportunity. And my internship experience at VSD has been incredibly rewarding. And I am excited to continue my journey in the field of VLSI. And the skills and knowledge I have acquired during my internship will surely help me in my future endeavors. And lastly, thanks to VSD for providing me with such a valuable experience. And I am looking forward to connecting with all of you who are in the meeting.
All right, good.
That's all. Thank you.
So good, Syed. Good introduction. So for all the participants, whenever you have a query, you can drop it in the chat box. The chat box will be open while the webinar is going on, and Syed and all other interns, our interns have joined in this particular webinar. So one of them should be able to help you out with all your queries. Okay. So let's begin. I'll share my screen. Yeah, Syed, you can share your LinkedIn profile. People are asking for it. I have to share the sound first. And
Welcome everyone. I am Sayyid Imaduddin.
is it audible, Syed and all of you? Just type yes in the chat box if it is audible.
An electronics engineering undergraduate student at Zakir Hussain College of Engineering and Technology, Aligarh Muslim University. The main goal of this webinar is to produce a layout for a 4-bit asynchronous up counter by utilizing the Align tool and Sky 130 PDK. Asynchronous up counter. Counters that are not synchronized with a clock signal are referred to as asynchronous counters. These types of counters use various clock signals to supply the flip-flops. When using a 4-bit asynchronous up counter, it is possible to count from 0 to 15. Circuit design. The figure depicts a mixed signal design that consists of both analog and digital components. The analog part includes a ring oscillator and ADC, while the digital part comprises T flip-flops used in the circuit design of a 4-bit asynchronous up counter. Schematic and layout. The analog portion of the design can be created using the xschem tool to draw the schematic. For the layout part of the analog design, the Align tool can be used. xschem tool. xschem is a software used for capturing schematics. It facilitates the construction of circuits with a hierarchical structure using a top-down methodology. The interface for the program is created using the TCL-TK toolkit, and TCL serves as the extension language. Sky 130 PDK. The Sky 130 is a hybrid technology that is now fully developed and matured with a range of 180 nanometer to 130 nanometer. Initially, it was created by Cypress Semiconductor and then made available to the general industry when it was spun out into Skywater technology. Currently, thanks to a collaboration between Skywater and Google, this technology is accessible to everyone. Thank you. This video aims to explain the purpose and function of Align tool and its configuration for 4-bit asynchronous up counter using Sky 130. Let's begin with an introduction to Align. So Align is analog layout intelligently generated from netlists. It was created as part of the DARPA program by the University of Minnesota, Texas A&M University, and Intel Corporation. We will answer some questions you might have regarding Align, such as its capabilities and benefits for us, and the types of input it accepts and the output it produces. Basically, Align helps us in creating the analog layout of any analog circuit using its SPICE netlist automatically. An instance of a 1-bit ADC is presented here. When we provide Align with the SPICE netlist for this particular 1-bit ADC, it will create the corresponding layout. Input and output of Align. The input format for Align is a SPICE netlist that should have a .sp extension, whereas the output files generated by Align are in the GDS and LEF formats. Prerequisites for Align. To use Align on a Windows machine, it is necessary to install Oracle VirtualBox with Ubuntu 20.04. The installation requires a minimum of 4 GB of RAM and at least 150 GB of hard disk space. The usage of Sky 130 Process Design Kit or PDK is necessary for creating the standard cells in their layout form. Additionally, certain tools such as Magic, xschem, and NetGen are also essential. That's all. Thank you.
Okay, so now we will see how to install all the prerequisites for Align. So go to your browser and type GitHub. So click on the first link and then go to search or jump to and type Sayyid Imaduddin slash MS VSD 4-bit UC. So click on the link and open the week 1 folder. So in this you have to go to readme, and here you will find the installation guide for Oracle VirtualBox and Ubuntu and all the required tools like Magic, Ngspice, NetGen, xschem, and OpenPDKs. So here is the download link for the Ubuntu and VirtualBox, and below that we have installation for Magic. You have to open your terminal and type these commands like sudo apt update and these. And in last there is dot configure and then make file, and then you have to type make it sudo make install, and then there is ngspice. Same you have to do with ngspice, and then netgen, xschem, and open pdks. You have to just type these commands in your terminal, and it will install all the prerequisites for Align. Here is the open pdk's link, github link. Now, and the this is the verifying your open pdks. You have to copy these xschem rc file and dot spice init file and magic rc file in the corresponding folders of xschem, magic, and netgen. So that's all. You have to install all these files from this these commands, written on the GitHub. You will find these on the my GitHub. Okay, that's all. Now we see how to install Align in our system. So go to your browser and type Align VLSI and hit enter. Click on the first link and go to the README. Here you will see the documentation, and then there is getting started. So here are two requirements which you have to satisfy, like GCC is greater than equals to 6.1.0 and Python is greater than equals to 3.7. And then there are two commands for export, and there is a clone the aligned source code. So we have to copy this git clone and then go to the folder where you have to set up your align. Here open the terminal and just paste the copy text and hit enter. It will take some time to download the align, so wait for it. Okay, it is downloaded now. Now go to the align public folder. Now open the terminal here and go to your browser. Yeah, here you will see the create a Python virtual environment. So type these three commands here. Okay, now source. Okay, now our pip is installed successfully. Okay, now install align as a user, like pip install -v dot. So it will take some time to install align. I'm skipping this part. You just need to follow all the commands written in the README of align, and then you will successfully install the align. So here we set up the Sky 130 PDK for align. So go to your browser and type align Sky 130 PDK and hit enter. Now click on the GitHub link align analog layout. Okay, click on the align PDK Sky 130 repository and then click on the code and just copy this HTTPS link and go to your align public folder and open terminal here and just type git clone and then paste your HTTP link here. Okay, it's downloaded. So open this folder and go to examples. Here are some examples. So we will see the buffer example here. Here you will see the buffer.sp spice file. So it is the spice file for buffer. Now go to your align public folder. Here you have to open the terminal. Just type python m when general and hit enter. And then write source general /bin /activate to activate the general. Okay, go to the work folder. Now type this schematic to layout.py and then give the address to your spice file with an extension of .sp. Here I am taking the buffer example, so I am giving part to it and then give a space -p and then write give part to your PDK. So it is Sky 130 PDK for me and hit enter. It will take 1 to 2 minutes depending on the circuit. Now the layout is generated for me in the GDS and LEF format. So I'm going to work folder, and here is the layout generated by the align. So now we will see the pre-layout and post-layout of ring oscillator using align. So go to ring oscillator folder, and here I created two folders, align and xschem. So in xschem, go to terminal and type xschem to open the xschem tool. So it is open now. So go to file and create new schematic. Now go to tools. Here is insert symbol option, and now go to Sky 130 library and Sky 130 FDPR. Now search for nfit 01v8.svm and click OK. Now left click, zoom to it. Now we have to change the width and number of FETs here from 1 to 2.1 and number of FETs to 2. It is required for it align. So now we have to duplicate the selection and left click. We can duplicate it by click on it, click on the and type C. Okay. So now shift I for open the choose symbol option. Now search for pfit 01v8.sym. Click on OK. Now again we have to change the width and number of FETs. Width is 2.1 and number of FETs is 2, and then press OK. Now C, again press C and left click. Now we have to do the wiring by pressing W and left click, W, left click, W, left click. So we have to do the wiring by pressing W. Connect the drain of NFET and PFETs. Now connect the gates terminals of NFET and PFETs. Okay, now connect the first inverter output to second, and second to third, and third to the output. And here we are connecting the VDDs of all the three PFETs. And here we are connecting the ground of ground to the source of all M and NFETs. Okay. And now we have to connect the output to the first inverter input. Okay, it is completed. So now we have to go to symbols and go to the xschem library devices, then search for ground symbol gnd.sym, click OK. Now connect the ground symbol to the source of the NFET. Now again shift I. Now search for the vdd.sym, click OK. It will be connected to the source of pfets. Okay, now it is connected. Now we have to go to vsource.sym and left click. Now connect the ground and the VDD to the vsource. Here we will give the 1.8 volt to the VDD. Okay. Now press shift I and search for open.sym, click OK and connect to the output and change the name to xxs to output OUT. Okay, now press shift I and search for code underscore shown.sym and press left click. Now we have to change S1 to library as we are going to insert the library, and just type the same commands if you are following the me from starting. So type .lib /usr /local/pd share /pdk /sky130a /libs.tech/ngspice, then /sky130.lib.spice space tt. Now, okay, select it, type m and move it to this. Okay, now again press shift I and select the code dot underscore shown, and left click. Now we are going to write the spice netlist here. So give it name spice, and here's some inverted commas, and type dot control, save all, and the next line in tran 0.01 nanoseconds to 3 nanosecond, and plot out, and then end c dot end c, and click OK. Okay, now press Control S and change the name to ring underscore oscillator. You can give any name to the file. Click OK. Now go to options and select a spice netlist and click on netlist and simulate. It will take some time to simulate the Ngspice. So here is the pre-layout output for ring oscillator. Now close it and just close it and close the xschem and go to the home directory and go to .xschem and then simulations. Here you will find the .spice file. Just copy it. Now go to your xschem folder. Here paste the copied file. Okay, now let's see what is there. Okay, here's the spice netlist. For the schematic we have created in xschem. So let's close it and just copy it and go to your align folder, align public folder, and then align pdk scansit, then go to examples. Here create a new folder with a name ring oscillator and then paste the copied file here, and now change the name from .spice to .sp extension, as align only take the .sp extension as input files. So here we have to do some changes. Just remove the simulated files. Okay, now we have to change the length to 0.15 to 150 e to the power minus 9, because align takes only in the format of e to the power minus 9, and for width we will change to e to the power minus 7. So you have to write this in the same format, because a line only take in length in the power e to the power minus 9 format and width in e to the power minus 7 format. So we have to change all the MOSFETs for with the same length and width. Okay, now it is completed. Just save the file and close it. Just take the JSON file from this and paste it here in the ring oscillator folder and change the name to ring oscillator.const .json. Now open the file and just change the VSS to GND. Now go to align public repository and open the terminal here and just type python m when general and then wait, source general /bin/activate to activate the general. Now go to the work folder, cd work. Now type the schematic to layout.py and give the part to the ring oscillator.sp file, which is in align pdk, and then examples, then ring oscillator folder, and then we have to give the part to pdk. So here we have sky130 pdk and then press enter. Okay, it will take some time. Okay, now it is created. So go to your work folder and here you will find 3 files of ring oscillator .lef.gds and .python.gds. Now copy these files and go to the folder ring oscillator folder and then align and then paste here. Or you can see the GDS file in the K layout. Okay, here you can see that ports and other things. Okay, now close it and open the terminal here and type magic. It will take technology automatically to sky130 as we have given the .magic RC file. Now go to file, read GDS. Now click on .gds file and open it. Now click S and then click X to see the MOSFETs. Now click S to select all the. Okay, now go to TKCon and type extract to local and extract all, then X to spice C thresh 0 and R thresh 0, and now ext to spice and enter. Now we have created the spice file from the. Now close it. Okay, so now we have created the spice file. Okay, here it is. Here we have to do some changes. Just we have to first remove these floating values, and here we have to remove this and this. Okay, now minimize it and go to xschem folder where we have the .spice pre-layout spice file. Here copy the simulation values from v1 vdd2 .ends. Now copy this and paste in our post layout file. Okay, just type x1 and then we have to give the sub circuit from this, copy and then paste here, and then we have to give the VDD GND and out. Now go to and like .ends. Okay, now after x1 just copy these VDD GND and outputs, paste it after x1 and then call this ring oscillator. Okay, it is done now. Just save this file. Okay, minimize it and go to the align folder and open the terminal here and type ngspice and ring oscillator _0.spice and hit enter. Okay, now you can see the post layout simulation of ring oscillator. It is the same as the pre-layout. Okay, here we will see the pre-layout and post-layout simulation of 1-bit ADC using Align. So go to the ADC 1-bit folder and go to xschem. Here I have already created the xschem file. So open the terminal and type xschem and the file name adc underscore 1bit.sch and hit enter. Now here you can see this schematic. Just press F for the full. Okay, so here you can see the VDD, VSS ports and the library file, and here all the circuit. So here simulations values. So just go to options and click on Spice netlist, then click on netlist and simulate it to see the pre-layout simulation. Wait for it. Now you can see the pre-layout simulation. So just close it and close it and close it. Okay, just okay. Now go to home. Okay, now .xschem and simulations. Here you will see the ADC underscore 1bit.spice. Just copy it and go to your align public folder and then align pdk sky 130 examples. Here create a new folder with ADC underscore 1-bit. Now paste your file inside this folder and change the extension from .spice to .sp, as align takes in spice file as .sp extension. Open it and just do some changes. Change the length to 150 minus 9 and width to 21e minus 7. Okay, it is done now. Save it, close this and just go to examples. Now open terminal here and type python m when general to open the environment. Now type source general bin slash activate to activate the general environment. Now go to cd work folder. Now type schematic to layout.py and then give path to the ADC 1-bit folder and give PDK path, which is sky 130 for us, and hit enter. It will take some time because our circuit is big, so just wait for it. Okay, now it is done. So go to your work folder and here you will see 3 files generated .gds, .lef and .python.gds. Just copy these files and go to your align folder inside ADC 1-bit and paste here. Okay, just open the terminal here and type magic, hit enter. It is open now. Just go to file and read GDS. Open this and click S and X. Now it is visible. So just minimize it and go to tcon main and type extract to local, extract all, ext to spice, c thresh 0, r thresh 0. Now ext to spice. Here we have generated the spice file. Just close this, and open the spice file here. Here we have to do some changes. Here you can see we have to copy this pre-layout Spice file to compare with this file. Just copy this and paste in the same folder where we have the post Spice file. Just open this, and we have to change according to this file. Just copy this and paste. Remove these floating values and now .ends. Okay, save this. So here you can see some ports are missing in the from the FETs. So we have to find these out, that which port we have to type where. So just search for all ports. So here are some missing ports. So we have to compare this with our pre-layout file. So as we give the NFET2, so for single FET in the pre-layout simulation, we have generated, Align has generated two FETs. So we have to do some changes here. Okay, now we have done the changes. So just close this. Okay, now open the terminal here and type Ngspice and the file name adc_1bit_0.spice to see the post layout simulation. Okay, just wait for it. It will take some time. Okay, so you can see the post layout simulation, which is the same as the pre-layout simulation for the ADC.
So all right, so that was the complete flow. Now, as you saw, there were a couple of changes that had to be done manually. So we are trying to work out, what are those manual things that needs to be done, and is there a way that it can be automated? So those are the things that are work in progress, and hopefully, if somebody has anybody from the Align core team has joined. The team from Professor Sachin or from University of Minnesota. if somebody from Align team has joined, they might be able to help us on the part which is not straightforward. But anyways, so this is an open problem statement for all of you. Now, there is a follow-up webinar on this one where we are going to show another example using Align. It is coming up very soon, and then there is another webinar on OpenFSOC. How they basically took all these components together and use the OpenFSOC tool to integrate the whole thing and put a chip around it. So that's what is coming up again by a set of students. So now the platform is open. I'll just unmute all of you, and if you have any questions, feedbacks, anything that you want to share with us, feel free to unmute yourself and ask any questions if you have. Anybody, if you have any queries, anybody has any questions, any doubts, anything, feel free to unmute and ask it over here. Anyone? So there are a couple of questions, I think, which are getting answered in the chat box. And apart from that, if we missed anything, feel free to ask those questions. So yeah, most of the questions are getting answered. Anybody has any queries? Any questions?
Hi, can you hear me? I'm Stefan.
Yeah, Stefan, xschem,
Okay.
xschem architect.
Yeah.
Oh, okay,
just a simple question. What was the reason for the port renaming in the last example? You had to rename a lot of very long net names, but I don't know why this happened.
Yeah, Syed. Syed, you can unmute yourself. Syed, are you there?
Yes, sir.
Yes, you can.
So,
you can
actually, you have to do some changes in the Magic where I opened the layout. So it will not require any changes in file. I did not
sorry, I didn't get. Was anybody able to hear him?
Hello.
Yeah, Syed. Yeah, can you please repeat? Syed, can you repeat?
Am I audible?
Yeah, you're audible now.
So I was saying that I have not changed the Magic file. So you have to change the port's name in the Magic of the layout generated by the Align. So you will not change the ports in the Spice file.
Okay, yeah, I got it. So it's a problem due to the the extraction from Magic. Okay, thank you.
Yeah.
All right. Anybody else has any queries? So there is one question. Yeah, Parvit, you can unmute.
Yeah, I want to address on the issue that Stefan was talking about. So the main thing is, as I said, Align is quite a bit in its early stage, and it has some issues. Like, for example, one of the biggest issues, it can generate up to some transistors. Like we faced during our internship period that maybe about 12 to some maybe 24 transistors was okay, but more than that it screwed up a lot. So another thing is during the generation of the Spice netlist from Magic, there were some ports that were missing, or most of the ports maybe were missing from the Spice netlist. So we had to rename it and relabel it right from the Magic itself after generating the layout from Align and opening it up. So that's one issue we have to further discuss, and maybe let's figure out that in later parts. We had to do a workaround on that so that temporarily we have a fix, but I think it can be a topic of another future perspective that we
Okay.
develop on that and fix it.
Okay. Good. All right, so a lot of work went. So Pramit, yours webinar is the next one, right? For the open episode, it's coming up.
Yes, sir. Yes,
Yes. Okay. So there is a follow-up webinar on this one, where we are integrating all the analog blocks and the digital blocks using OpenFSOC. It's a initiative by University of Michigan by Professor Mehdi, and we also did a entire. In fact, Pramit will be presenting the whole thing in coming days, like in 3-4 days from now. I'm going to send out an email for that as well. So that is also going to be an interesting webinar, because that's a follow-up of what Syed did in this particular webinar. Okay. All right. So if there are any questions, you can of course drop an email or put a message on the Slack channel. Anything is fine. And that's all for this one. So now closing ceremony. So we basically ask everybody to open up their cameras, and so that we can take a group photo. It's just a kind of a memory that or collage that we save at the end of every webinar. So everyone can just open up their camera. So Anaga is going to take a quick photo, and then we can all sign off from there. Yeah, Anaga, can you just open up your camera? Yes, so she's here, and everybody just let's see your faces. So that's Stephen. Okay, nice to meet you. I'm glad you attended the whole webinar, so that we can connect xschem and align in the future. Maybe a button saying that. Yeah.
Thank you. Yeah, very clear, very helpful, and very well done.
Oh, okay. Syed, that was for you. All right, so everybody just turn on their cameras. We'll take a quick photo. We'll take a quick photo session. Minsang, Mihai, Rupesh, Sashwat, Kaushik. Okay, and do this V is for victory, and Anaga is going to take a quick photo. Anaga done? All right, thanks all of you. Thanks a lot for joining, and I'll send the link for the follow-up webinar in a couple of days from now. Thank you so much for joining. Bye. Bye.
Thank you, sir. Bye.
Thank you. Bye.